Welcome back to Learning Data Science on the Ethereum Blockchain with omnianalytics. In the last video, we learned about R basics. In this video, we'll learn about data structures. All the files used in this video will be provided on GitHub. Check out the links in the description box to find out more about our Gitcoin grant and CryptoPunks. Let's get started. The first data structure we'll look at is data frames. Data frames are the workhorse of our objects. They are structured by rows and columns and can be indexed. Each column is a specified variable type. Column names can be used to index a variable. Advice for naming variables stated earlier in the course applies to editing column names. Data frames can be specified by grouping vectors of equal length as columns. To index a data frame, we need to remember the elements that we discussed in our basics. Check out that video for more information. Elements are indexed using square brackets. The code dfij will select the element in the ith row and the jth column. If we remove the I, this will select the entire jth column and treat it as a vector. And if we remove the j, this will select the entire ith row and treat it as a vector. Logical vectors can be used in place of I and j to subset the row and columns. You can also add new variables to a data frame by creating a new vector that is the same length as other columns, appending the new column to the data frame using the $ operator, or adding the new data frame column. Remember, the new data frame column will adopt the name of the vector. Let's have a quick demo. First, let's load the punks dataset. Select the 6th column of the dataset. Now select the date and skin columns, the 6th and 10th columns. Let's select the ID column with the $ operator. We can now determine the row location in our data where the ID is 9126. We can also display part of the punks dataset where the ID is 9126 by subsetting rows. Let's try creating our own data frame. We can do this using the data.frame function. It should be noted that in the data frame, each column has to have the same length. We can use the names function to rename columns. In this example, we use the names function to set the first column to lowercase. We can also rename all the columns at once using the call names command. Now it's your turn. Construct a data frame where column 1 contains any 5 punks and column 2 is their slot number. Select only the rows where the slot number is even. Determine which rows of the punks dataset contain the alien type. Here are the answers for you to look at. The next data structure is lists. Lists are a structured collection of R objects. R objects in a list do not need to be the same type. Create lists using the list function. Lists are indexed using double square brackets to select an object. Let's have a look at an example. Let's create a list containing a matrix of size 2 by 5, a vector of length 5, and a string. Note that unlike data frames, lists contain elements of varying sizes and structures. Let's use indexing to select the second list element. This code prints the string. CryptoPunks are awesome. Your turn. Create a list containing mydf as well as a vector of length 7 containing different punk skins. Use indexing to select mydf from your list. Here are the answers for you to look at. There are a few different ways to examine objects in R. We have already seen head, tail, summary, structure, and length, but there's also dim, which gives the dimensions of the object. We can examine the first two values of an object by passing the n parameter to the head function. If we pass n equals 2, we find that this displays only the first two rows of the punks dataset. Here we can see the structure function passed with punks. Now it's your turn. View the last 4 rows of the punks dataset. How many rows are in the punks dataset? Try finding this using dim or indexing plus length. Here are the answers for you to look at. The final stage is to look at working with output from a function. You can save the output from a function as an object. An object is generally a list of output objects. You can extract items from the output for further computing. We can examine objects using functions like structure. Let's demonstrate. We're going to apply a t-test using the punks dataset to see if the sale price in crypto for punks with 1 slot and 7 slots are statistically different. A t-test can only handle 2 groups, so we use a subset of the other slots. In this demonstration, we will save the output of the t-test to an object called t-out. This t-test can be interpreted as having shown no statistical difference in the average sale price in crypto between the 1 and 7 slot punks. Let's have a look at the structure of this object. Let's extract a p-value from the t-out object. Since this is simply a list, we can use our regular indexing, t-out $p.value. We could also use list indexing. Now it's your turn. Return the p-value from the t-test, comparing the difference between the sale price in USD from the 2 and 4 slot punks. What does this p-value imply? Here are the answers for you to look at. Thanks for sticking with us and learning about data structures in R. In the next video, we will be looking at case studies in the Ethereum blockchain. See you in the next one.